Hello, this is Ali from Team 12635 Curiosity Robotics in Palo Alto, California. This is the second video of the design process series, and we will be looking into the first step of the design process, defining the problem and specifying its requirements. Defining the problem is the first step when starting the first cycle, but otherwise, it is the step after testing your previous solution. When defining the problem the first time, ask yourself, what does the robot need to do? Does the robot need to pick up a cube, shoot a tennis ball, move a box, or know where it is on the field? If this isn't your first iteration, ask yourself, what is the problem with the existing design? Does it do what it was supposed to do? Did it break? Did it meet the requirements? Where is there room for improvement? Remember to be as specific as possible. After you have defined the problem, begin to specify its requirements. There are many different requirements you can set, and the most general ones are listed here. Make sure the requirements you set can be measured, so try to use numbers if possible. For example, speed. How fast the robot has to do its job. Instead of saying fast, specify 2 meters per second or pick up a block in 1 second. Accuracy. How precise the robot needs to be. Can it pick up a ball if it's not aligned perfectly? Specify something like pick up a ball from a 20 centimeter section or place a block within 5 centimeters of the wanted location. Reliability. How successful is the robot? You generally want to be as successful as possible, mostly over 90% of the time. Size. Most likely, your mechanism needs to be under a certain size. Does it have to fit in between the sides of the drivetrain? Specify the exact measurements it should not exceed, and maybe even the minimal measurements. Durability. Does it break when used? In most matches, two robots will crash into one another, so your robot should be built strong enough to withstand these things. To specify, declare in what instances and speeds it should not break. Materials. What materials can you build out of? Can you use a 3D printer? Specify all materials you have available. These are not the only requirements you can set. They are just general ones to get started with the process, so feel free to come up with new ones. So, why do we make these requirements? Actually, the more restricted you are, the more creative you are forced to be. You're forced to think outside the box and come up with creative solutions. So the more you make constraints, the more creative your end product will be. Let's try putting the first step of the design process into practice with an example. Throughout these next couple of videos, we will be designing an intake that picks up bouncy balls. The first thing we have to do is define the problem. Take a moment to pause the video and read through this example game manual. While you read, try to come up with a problem statement for the intake. You might have defined the problem like this: pick up bouncy balls. This is correct, but try to be as specific as possible. How could you describe it in more detail? You could say, pick up multiple bouncy balls from the corner of the field's floor and deposit them into a bucket. Now this is more specific and something that you can work with. Next, we must specify the requirements. What does the mechanism that picks up the bouncy balls need to have? We can begin creating a list here. For speed, we want it to pick up 2 balls per second, so it will only take 1 second to pick up the balls for teleop, and then we can intake many balls fast during in-game. For accuracy, we want to be able to pick up a ball if it is anywhere between the two sides of the drivetrain, or from a width of 12 inches. For reliability, we want 90% of the balls to go into the bucket. We can increase this number later, but as this is the first design, we will set slightly lower standards. For size, we want it to fit between the sides of the drivetrain and not to be higher than 20 centimeters off the ground. For durability, we want it not to break when used in a match. This would mean that it could withstand getting rammed into a wall, spinning at high speeds, and would not break while picking up balls. For materials, We can use Go Buildup parts, CNC plates, and 3D printed parts. The rest of these are not necessary but are important for the specific problem. The design has to use only one motor, be as lightweight as possible, and should be finished in a month. That's it for the first step of the Curiosity design process, and in the next video we will be covering research. Thank you for watching!